Alright, today I will be correcting a trigonometric integral that was primarily wrong, but now I'm going to correct it. This trigonometric integral that I'm talking about is the integral of sine to the 6th power of x times cosine to the 6th power of x dx. So, this integral, I made a video about it, but I actually got the answer to the integral of sine to the 6th power of x, but cosine to the 5th power of x, which is moderately easier than this one, by a margin, quite a margin. So let's get into it. So sine to the 6th power of x is 1/2 times 1 minus cos 2x, which is sine squared x, but cubed. And then cosine to the 6th power of x is 1/2 times 1 plus cos 2x, that's cos squared x, to the power of 3. We're doing the power reducing formula here. But since this is 1/2 to the power of 3, this also is 1/2 to the power of 3, so 1/2 to the power of 3 multiplied by 1/2 to the power of 3 is 1/2 to the power of 6, which is 1/64, and we can bring that outside the integral because it's a constant. 1 minus cos 2x cubed times 1 plus cos 2x cubed. So let's do another algebraic formula. X to the n times y to the n is equal to xy in parentheses to the power of n. So let's say this is x and this is y. So we can multiply this and then put it to the power of 3 using this algebra formula. That's pretty simple, but it's very useful. 1 minus cos 2x times 1 plus cos 2x to the power of 3 dx. This is equal to 1/64 times the integral of 1 minus cos squared 2x to the power of 3, because I multiplied this and this and got this and to the power of 3. 1/64 times the integral 1 minus cosine squared of 2x is sine squared 2x cubed. 1/64 times the integral sine to the 6th of 2x dx. So we went from this to this. It's a big step, because we don't have this annoying cosine 6 of x. We can use the power reducing formula for trigonometry once more. 1/2 1 minus cos 2x to the power of 3 with respect to x. Next, this is 4x because there's this 2x here, because we multiply, we substitute x for 2x, since this was cosine 2x, we substitute x for 2x, this is cosine 4x. So 1/2 cubed is 1/8, so 1/64 becomes 1/512, because we can bring that fraction to the outside. 1 minus cos 4x cubed. Well, what's 1 minus cosine 4x cubed? 1 minus to the power of 3. This is 1 minus cos 4x times 1 minus cos 4x times 1 minus cos 4x. This is equal to cos squared of 4x minus 2 cos of 4x plus 1 times 1 minus cos 4x. I multiplied these two and got this because I squared it. So this multiplied by this is cosine squared x, 4x. This multiplied by this is minus 2 cos of 4x. And this multiplied by this is plus 1. And cosine squared 4x multiplied by negative cos 4x is minus cos cubed of 4x. Negative 2 cos 4x times cos 4x is plus 2 cos squared of 4x. And then positive 1 times negative cosine 4x is, of course, negative cosine 4x. So that is our new integral. 1 over 512 times the integral of negative cos cubed 4x plus minus 2 cos 4x minus cos squared 2x plus 2 cos squared of x is 3 cos squared of 4x, because these each had 4x in it. I'm doing like terms. Negative 2 cosine of 4x minus cosine of 4x is negative 3 cosine of 4x. And then plus 1 dx. I could do this one, the integral of 1 with respect to x is just x. So I can put that outside. X over 512, I multiplied by the constant outside. The integral of negative 3 cosine of 4x with respect to x is negative 3 sine 4x, but divided by 4 using the u substitution. So x over 512 minus 3/4 sine 4x plus 1 over 512, the integral of negative cos cubed of 4x plus 3 cos squared 4x. So we're gradually reducing the powers over the steps. So instead of an aggressive sine 6x, cos 6x, we have cos cubed and cos squared, which are much easier to work with. I equals x over 512 minus 3/4 sine of 4x. But this, let's separate the integrals. This is the integral of cos cubed of x negative. This is cos squared x times cos of x. And do you know what I'm going to do here? Cos squared x is 1 minus sine squared x. So this is negative integral 1 minus sine squared x times cos x dx. Hold up. You can do u substitution because this is sine x and the derivative of sine x is cosine x. U equals sine x. Du is cos x dx. This is our du. So this is negative integral 1 minus u squared du. Hold up. This is actually 4x, but let's say we substituted for t and divided by 4. So 1/4 cos cubed 4x. This is the integral. We can flip this d sign and flip this sign. U squared minus 1 du is u cubed over 3 minus u. Plus your constant, of course. This is cos cubed. So u was sine cubed of 4x over 3 minus sine 4x. But we forgot to divide it by 4, so is sine cubed 4x divided by 12 minus sine 4x over 4. So this is plus sine cubed 4x divided by 12 times 512, which I don't even know. That's a gigantic number. But this is for negative. This is a negative right here. So I need to actually flip the signs. So much going on. Minus sine. This is a minus. A minus. Sine cubed of 4x divided by 12 times 512. And then this minus becomes a plus. Plus sine 4x over 48, which is 512 times 4. Plus the integral 3 cos squared 4x dx. All we have to do is this. All we gotta do is that. Right there. So let's do 3 times the integral cos squared 4x. Now we'll do a t substitution. T is 4x. dt is 4 dx. So that means 1/4 dt is dx. So we'll take that 1/4 outside which leads to 3/4 cos squared t dt. So since we need to use the power reducing formula once more, just once more, 1/2 1 plus cos 2t dt is 3/8 integral 1 plus cos 2t dt. This is 3/8 t plus 3/8 sine 2t. So since t was 4x, let's do 3/8 times 4x, which is 3x over 2, and then plus 3/8 times sine 2t, which is 3/8 times sine 8t, because this is cos squared 4x. We multiply each by 4 and divide by 4 because u substitution. So that leads to I equals x over 512 minus 3 over 4 times sine 4x minus sine cubed 4x over 12 times 512 plus sine 4x over 2048 plus 3x over 2 plus 3/8 sine 8x plus our constant. I know this is an unsimplified answer, but that is it for now. That is it for now. That was a lot of work, but I got the answer. I'm not sure if it's right. Probably wrong.